The subnets keyword is extremely important with OSPF when performing redistribution. If you perform any type of variable length subnet masking in your topology, the subnets keyword is of extreme importance. Why is that? Well, let's examine this particular network entry. Is that a classful or classless network? It's classful because this is a Class A address and this is a Class A default subnet mask. What is 172.16.0.0/16? Is that classful or classless? Again, it's a classful address because this is a Class B address and this is a Class B default subnet mask. Now, what about this address here? 10.1.1.0/24. And what about 172.16.33.0/29? Are those classful or classless networks? Well, they're classless networks. They have been subnetted from the classful networks of 10.0.0/8 and 172.16.0.0/16. So they're classless. They're no longer using their default subnet masks. So we have a Class A with a /24 and we have a Class B with a /29. When performing redistribution with OSPF, if we fail to include the subnets keyword, only classful networks are redistributed. That's it. Only classful. What that means is the OSPF router is going to look in the routing table and see if there is a Class A network with a /8, or a Class B network with a /16, or a Class C network with a /24. If it finds any of those, it redistributes it. That's it. Would this be redistributed? Nope. Would this be redistributed? Nope. Why? Because they're not classful. The only way to get these ones here, these two, redistributed because they're classless is to include the subnets keyword. Without that subnets keyword, then they're not going to be redistributed. Let's analyze a redistribution problem in our environment. Now, we have a widespread problem here. We have users in the OSPF domain that are complaining that they are not able to access resources in the EIGRP autonomous system. And we have users in the EIGRP autonomous system who are complaining that they can't access resources in the OSPF domain. So this is widespread throughout our entire network. If we access R1 and we type in the show IP route command and we analyze the routes we have learned, you will verify on R1 that the OSPF routes are there. Meaning that as users send traffic towards the OSPF domain, R1 is able to route that traffic over to R3. And we can verify those routes with the DEX. There's the 34.0 network. There's the 32.0 network right here. 32.128, 32.192. They're all external to the EIGRP autonomous system. So it appears that redistribution into EIGRP is working right now. But let's go over to R4. Show IP route. Do we have any external routes here? Yeah, it looks like we have one external route, but it's the 172.16.32.192 network. That's over on R7. Right now it says it's in OSPF area 567, but it's not. It's actually being redistributed, that 172.16.32.192 network. It's a directly connected network, but it's being redistributed into our OSPF domain. That makes that OSPF area a not so stubby area. But I don't see anything else in relation to our what? Our 10 networks. And from our EIGRP autonomous system, they're not listed there at all. So it seems like redistribution is only working one way right now. OSPF routes are getting into the EIGRP autonomous system, but the EIGRP routes are not getting into the OSPF autonomous system. So if we analyze R3 and we look at the show IP EIGRP topology table, we'll see here that those OSPF routes are in the EIGRP topology table. So they're successfully being redistributed on R3 into EIGRP from OSPF. But if we issue the show IP OSPF database command, we'll see that there is a lack of type 5 LSAs on R3. I only see the default route and the 172.16.32.192 network listed. I don't see any of the other 10 networks from the EIGRP autonomous system. When you perform redistribution in R3, it will place type 5 entries in the database for all of those other networks. So this confirms for us that redistribution in R3 is not working properly. But remember, in order to do redistribution, those entries have to be in the routing table. So we type in show IP route OSPF. Are those routes even being learned by R3? And the answer is yes, there they are. 32.128 is listed, 32.192 is listed. We have all those routes. If we look at EIGRP, show IP route EIGRP, we can see that the 10 networks are listed there. So these 10 networks are the ones, since they're in the routing table, that are going to be redistributed into the OSPF process, placed in the OSPF database so they can be advertised to the other OSPF routers using link state advertisements. So why isn't this working properly? Do we even have redistribution configured? Show run, show IP protocols. Show IP protocols for the OSPF process indicates that we are performing redistribution. So we're taking external routes from EIGRP Autonomous System 100, and we are applying a metric of 35 to them as we're performing redistribution. So why isn't it working? What type of routes are these? These are classless routes. That's what they are. Classful routes would be routes that have their default class with their default subnet mask. These are Class A networks. Do they have their default subnet mask? No, not at all. Not at all. They've been subnetting. So since they've been subnetted, we need a special keyword during the redistribution process. It's the subnets keyword. And the subnets keyword says redistribute those classful networks. And according to this output here, we are missing that subnets keyword. So let's examine the running config show run pipe to section router OSPF, and we'll see in this output that redistribute EIGRP 100 metric 35 metric type 1. I don't see the subnets keyword. So this is our issue. Let's copy that. Configure terminal. Router OSPF1, redistribute, etc., subnets. So there's the subnets keyword I applied. Look at the output of show IP protocols. You can now see here that it says we are including subnets in redistribution. So we're including classless networks, which are our 10 networks are within our EIGRP autonomous system. And now if we look at the output of show IP OSPF database, we'll see down at the bottom of the database the 10.1.0.10 network, 10.1.1.16, 10.1.1.32, 10.1.1.48. They're all listed there now. They're all being successfully redistributed into OSPF. And if we jump over to R4 and we type in show IP route, we can see that we have our 10 networks now listed. They are E1 because the metric type was set to 1. And the metric, remember, if you recall, it was set to 35. So now 35 plus 1, because of the bandwidth between R3 and R4, is a gigabit Ethernet with a cost of 1. It's now 36. So without that subnets keyword, these classless networks were not being redistributed.